Hey guys, Mr. Backwork here. In this video, we're going to look at graphing an inequality. So as we're looking at inequalities, an ordered pair, xy, is a solution of an inequality if it satisfies the inequality. So for example, if we were looking at the inequality y is less than 2x plus 3, and we wanted to check the ordered pair 2, 5. Well, 2 is our x value and 5 is our y value, so we're going to take those and plug those in where they need to go in our inequality. So I'm going to plug in the 5 on the left-hand side, and we're going to check to see, is that less than 2 times 2 plus 3? Well, 2 times 2 is 4, plus 3 is 7, and 5 is in fact less than 7. So this 2, 5 ordered pair satisfies this inequality. It works in this inequality. So 2, 5 is a solution for this inequality. Now, as we're looking at graphing an inequality, the graph of an inequality consists of all of the ordered pairs that are solutions of the inequality. And there's a couple of steps that we're going to use to help us with drawing the graph of an inequality. And step number 1 says that we're going to draw the graph of the equation that we get if we replace the inequality symbol with an equal sign. Now, as far as graphing out the line, we're going to use a dashed line if the inequality is just less than or just greater than. And we're going to use a solid line if the inequality is less than or equal to or greater than or equal to. And then what we're going to do after we have that line plotted out is we're going to check a point that's not on the line, and we're going to see if it satisfies the inequality. If it does, we're going to shade on the same side of the region that includes that point. But if it doesn't, then we're going to shade on the opposite side of our line. So in this first example, we're going to graph out a linear inequality, and we're going to look at the inequality y is greater than or equal to 2x plus 3. And step number 1 said that we're going to replace the inequality symbol with an equal sign, and we're going to graph out that equation. Now this is a nice y equals mx plus b equation. So if I look at that b value on the end, we've got a 3 there, meaning that my y-intercept is at 3. Then we've got a slope of 2, so we're going to go up 2 over 1. And I'm going to do that a few times so I can get a nice picture of what my line is going to look like. Now we have to decide as we draw on our line, is this going to be a dotted line or a solid line? So we look at our inequality. My inequality has the equals to line underneath it, so we're going to draw this out with a solid line. So there's the line for our inequality, and that's called the boundary line. Now what we need to do next is we need to pick a point that we can test out in our inequality to see if it works. I personally like to use the point 0, 0 if it's available. So as long as our line is not going through the origin, then we're going to be able to use that 0, 0 point. If our line does go through the origin, then we'll just have to pick a different point to test out. So I'm going to plug in 0, 0 in my inequality to see if it works or not. So I plug in 0 on the left-hand side is greater than or equal to 2 times 0 plus 3. Well, 2 times 0 is 0, and 0 plus 3 is 3. So this inequality is saying 0 is greater than or equal to 3. And that's not true because 0 is not bigger than 3. So we tried the point 0, 0, which is below my line. It didn't work, so that means I need to shade on the opposite side of this boundary line. So I need to shade above this red solid line that we just drew in. So that whole region above this red line, and including the red line, because we've got that equals to portion with our inequality, those are all solutions to this inequality. So that's the graph of our inequality. Now here in this example, we've got a couple of special kinds of linear inequalities. The first one, we've got x is greater than or equal to 2. So if we get rid of the inequality symbol and replace it with just an equal sign, then this says x equals 2. And we have to remember that an x equals equation is a vertical line through that specific x value. Now because our inequality does have the equals to line underneath it, then as we draw this out, it's going to be a solid vertical line through that x value of 2. Now, as far as our shading, we want x values that are greater than or equal to 2. So if we think about where x values are bigger than 2, that's going to be on the right-hand side of this line. So the solution set would be the entire region to the right of that line and including the line. Now for our second special inequality over here, we've got y is less than negative 3. And if we replace that inequality symbol with just an equal sign, this says y equals negative 3. Now, y equals a number is a flat horizontal line through that specific y value. So as we look at graphing this one out, we're going to have a flat horizontal line through the y value of negative 3. But as we look at our inequality, it does not have the equals to line underneath it. So we're going to have a dotted line through the y value of negative 3. Now, if we want all of the y values that are less than negative 3, then those are going to be all the y values that are below negative 3. So the solution set is going to be the region below this dotted line. But this time we're not including the line because we don't have our equals to symbol with our inequality. Now, as we're looking at this last example here, we're going to graph out a quadratic inequality. So we're going to look at the inequality y is greater than or equal to x squared minus 3. Now the process is going to be exactly the same. So first I'm going to get rid of the inequality and replace it with an equal sign so that we can draw that graph. So we get y equals x squared minus 3. So this is going to be an x squared parabola shifted down 3 spaces. So I'm going to plot out some points for that graph. And if we need to make an x and y table for this in order to get some ordered pairs, that's fine. So these are the ordered pairs that I'm going to plot out to give me my boundary line. Now, because my inequality does have the equals to line, then I'm going to draw out the graph with a solid line. So we get a graph that looks something like that parabola. Now we need to pick a point to test out to see if it satisfies the inequality or not. My graph does not go through the origin, so it's going to be safe for me to use the ordered pair 0, 0. So if I plug in those x and y values, we get 0 is greater than or equal to 0 squared minus 3. 0 squared is 0, minus 3 is negative 3. And if we look, 0 is in fact greater than negative 3. So this ordered pair 0, 0 does satisfy our inequality. So we want to shade on the same region as this 0, 0 point. So we're going to be shading inside of this parabola to get our solution set. That's going to be it for this video. Thanks for watching.